A tree diagram is a really nice graphical way to see the probability of something happening over and over. And believe it or not, it really does look like a tree, as you're about to find out. So let me show you how we can draw a tree diagram to find the probability of something happening in a coin toss. Maybe, I don't know, we've been given a problem that looks like this. Use a tree diagram to find the probability of tossing a coin 3 times and getting 3 heads. So every time you throw the coin, it lands with heads facing up. What's the probability of that? Well, without a tree diagram, it might be a little confusing to solve that at first. But before we start drawing our tree, let's have a quick look at a coin. A penny, as I'm sure you know, has a front and a back. So when you toss a coin, the probability of it landing tails, we would say, is 1/2. And the probability of it landing with the heads showing is also 1/2. Because, as you recall, in probability, all events must add up to 1. And a half plus a half, well, that makes 1. Keep that in mind for whenever you use a tree diagram. All right, now I think we're ready to start the tree diagram with our first coin toss. All right, so imagine you have one of these pennies in your hand and you walk up to a table and you toss it on the table. What are the two possible outcomes? Well, the coin could land with the head showing, or the coin could also land with the tail showing. There's two different outcomes. That's why we made 2 branches. Let's label the branches. I'll call this branch H for head and this branch T for tails. Now when we start, there's 2 outcomes. So what's the probability? Well, the probability of landing with a head, as we mentioned, was 1/2. So we'll label that branch with the probability of 1/2. And there's also a 1/2 probability of landing with the tails showing. And that's the first coin toss. So let's take the penny off the table and we'll do a second coin toss. Now on the second coin toss, what are the 2 possibilities? Well, the same thing. It could land with the heads showing, or it could land with the tails showing. So we make 2 more branches. But you also could have thrown the first coin and it landed with the heads showing. And then on the second coin toss, there's 2 possibilities. You could have landed with the heads showing, or you could have landed with the tails showing. So we make 2 more branches on this side. See how it's starting to grow? And just like the first coin toss, we'll label all the branches of the second coin toss. This branch represents landing with a head showing on the second coin toss. This branch represents a tail showing on the second coin toss. And we'll do the same on this side. And our probabilities for all these branches are the same. They're all 1/2. It'll always be 1/2 because there's 2 sides to a coin. If the coin somehow magically had 3 sides, we'd be talking about 1/3. All right, let's move on to the final third coin toss. By now you can sort of start to see how this is growing like a tree. What we do is for every arrow tip, we add 2 more branches because there's 2 possibilities. So I could have thrown a heads for the last coin toss or a tails, and I do that for each new branch, just like this. And there we go, we have the final coin toss. And we'll just add in our labels for each branch. That one's a heads, that one's a tail, and so on. Heads and tail. So you can really see making a tree diagram is just all about making a pattern and then continuing that pattern over and over. And finally, I'll just label all of these branches with the probability of 1/2. Now that my tree diagram is complete, I can use it to answer all sort of questions. For instance, what's the probability of getting 3 heads on 3 coin tosses? To do that, I simply start at the beginning and I trace a path where I find 3 H's in a row because I'm looking for 3 heads. There's the path I want. Now to find the probability of all three heads occurring, I just multiply the probability at each branch with each other. So I have 1/2 times 1/2 times another 1/2 for the last branch. And that will give me 2 times 2 times 2, 1/8. So the probability of throwing a coin 3 times and getting 3 heads is 1/8. A tree diagram is also useful because it'll tell me how many total different ways there are to throw a coin 3 times. If I just count up the final tips here, 1, 2, 3, 4, 5, 6, 7, 8, there's 8 different ways that I can throw a coin 3 times. And now it's your turn to try doing a tree diagram. Let's give you this practice problem. Use a tree diagram to find the probability of tossing a coin 2 times and getting 2 tails. Okay, so try that by drawing a tree diagram like I showed you on the left. But remember, it's only for 2 coin tosses. Here's what your tree diagram should have looked like. And the final answer is 1/4